Okay, today we're going to be talking about the definite integral, and we have already been talking a little bit about the definite integral, but we have so far learned how to use approximation methods to get the area underneath a curve. Today we're actually going to get the exact area underneath the curve. However, everything that we're going to do today is involving some sort of geometrical shape, either a rectangle, square, or circle, semicircle, or triangle. And we know the formulas for the area of these shapes, and so we will use that in order to get the exact area under the curve, which is an integral. So let's see if we can get started here. We want to find the integral from 1 to 3 of 4. Well, y equals 4 is just a horizontal line, and so we're going to go from 1 to 3, and so if we just draw the little lines up here, we will see that this is just a rectangle, and this is the line y equals 4. So we have a height of 4 and a width of 2, so that is simply going to be 8, and that's all there is to it. All right, the next one is a linear function, and it has a y-intercept of 2, so we'll go up 2, we'll put a point. And the slope is 1, so up 1 over 1, up 1 over 1, up 1 over 1, so on and so forth. And we're going from 0 to 3, so that's 1, that's 2, that's 3. So basically, we have this shape right here. Now, this is a trapezoid. However, a lot of people don't remember the formula for the area of a trapezoid. So maybe it'd be easier if we broke this up into a triangle, which we'll do in blue, and then the rectangle, which we'll do in red. All right, so let's see what the answer would be here. The red is going to be a 3 by 2 rectangle, so that's going to give us an area of 6. All right, because we're going over 3 and up 2. And then the triangle is going to be, well, let's remember, base times height divided by 2. So you have to remember here that this point is going to be the point 3, 5. And you get that if you plug in 3 into the function. This point is 0, 2. So the height of this triangle is going to be 3 because it goes from 5 to 2. So that's going to be 3. So we'll put 3. The base is just going to be 3 as well, over 2. So 9 over 2 is 4.5, so we end up getting 10.5. All right, this next one is actually a shape that many people really don't recognize easily, but it is a semicircle. It is a semicircle. It's the upper half of a circle that has a radius of 2, and it is centered at the origin. It comes from this formula here for a circle, x squared plus y squared equals r squared. And this is a circle centered at 0, 0. And the radius is over here. So if you move the x squared over and take the square root, you get something that looks like this. So the radius is going to be 2 up, 2 right, 2 left. And let's see if we can draw a nice semicircle. Ooh, it looks a little bit more like an oval, but that's okay. And we can go ahead and find the area of this. So let me shade that in there. So we're going to find the area of that semicircle. So we'll do pi r squared divided by 2. And we're going from -2 to 2, so we need the whole semicircle. Pay attention to these limits of integration. If this was 0 to 2, then you'd be needing a quarter of a circle and so forth. So this is going to give us pi. The radius is 2 squared over 2, so that's 4 over 2, so that's 2 pi. Let's talk about some properties of definite integrals. The first idea is if you're integrating from a number a to that same number, then the integral is going to be 0. The reason for that is because you're not getting any area underneath the curve. You're integrating from a number to that same number. There's no area underneath the curve, so therefore the integral would be 0. All right, this next one is a pretty important one here. If you're trying to integrate from a to b, you can break that integral up into the integral from a to some number c, which c is in between a and b, plus that same number c to b. And basically the idea is that, let me see if I can circle it. If these two numbers are the same, then the integral that you get is going to basically go from a to b. All right? And that's the idea there. Here, the integral from b to a is equal to the opposite of the integral from a to b. So the idea here is that if you switch the limits of integration, you have to change it to a negative. Here is pretty simple. A to b, this k is some constant. All this is saying is that you can take any constant, which I highly recommend, outside of the integral, and then you can just integrate the function as normal and then multiply your integral times k. And then the next one is the sum rule. Integrating from a to b, f of x plus or minus g of x. You can break it up into the integral from a to b of f of x, so some function, plus the integral a to b of g of x. Notice there is no multiplication rule here, so make sure that you don't do this ever. So if, let's say you have f of x times g of x, this is not equal to the integral a to b f of x dx times the integral from a to b g of x dx. That is not allowed, so I'm going to put a big red X on that. And the idea is we have some other techniques for integrating things like that. All right, the last thing we want to look at is if you have area above the x-axis, then that's going to be a positive value. And then any area below the x-axis is going to be considered negative. So let's apply this to the problems that follow. We want to use the properties that I just went over in order to answer the following questions. Given the integral from 0 to 3 of some function we don't know is 4, and the integral from 3 to 6 of some function, that same function, is -1, evaluate the following. Okay, we want to integrate, we want to find 6 to 0. So I would highly recommend that you always integrate from left to right like you're reading a book. So let me write that down. Integrate from left to right, just like you are reading a book. All right, so we're going to rewrite this, and we're going to rewrite it as negative the integral from 0 to 6 of f of x dx. So we're going to put a negative, and then we're going to break this thing up as the integral from 0 to 3 of f of x dx plus the integral from 3 to 6 f of x dx. And then we're going to look at, the integral from 0 to 3 of f of x dx is 4, so we're going to put a negative, and we're going to put a 4 right there. And then from 3 to 6 is going to be -1. So 4 minus 1 is 3, and then times a negative makes it a -3. That's pretty simple. All right, now we have the integral from 6 to 3. Well, if you notice, that's just the reverse of 3 to 6. So if 3 to 6 is -1, then 6 to 3 is +1. So that's a pretty simple one as well. Here we have the idea that you're integrating from a number to that same number. That means there's no area underneath the curve, so then you're going to get a 0. So that's once again an easy one. And then here, if we notice that the integral is going from 3 to 6, so that matches up with this. But we have a -5 here, but we can apply the constant multiple rule, which means we're going to bring the -5 out to the front. And then we're going to integrate from 3 to 6 of the function f of x dx. And we know that that is -1, so -5 times a -1 is simply 5. So this is pretty easy stuff. All right, here we have 3 functions, and we want to find the integral using areas. So the first one we've seen earlier in the first example here. This is just going to be, once again, a semicircle. And so if it's a semicircle, it has a radius of 4. So we'll just go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And this is the upper half of it. So it's going to be looking something like this. All right. And we are integrating from -4 to 0. So let me shade that in. That's basically going to be that little area right there, which is a quarter of a circle. So we're going to do pi r squared over 4, which is the area of a circle divided by 4. So that's going to be pi, and then the radius is 4, so that's going to be 16 when you square it, divided by 4, and that's going to give you 4 pi. All right, so now we're going to do the absolute value function. And this one is also a pretty simple one. And so now we have the absolute value of x, and we know that that's basically just a v, but the idea is where is it going to start and stop. So let's just draw a line there, and then we'll draw a line there. All right, and we are going from -2 to 1. So we'll make that -2, we'll make that 1. So draw some lines up there to give us our area. So basically, the area that we're looking for is this area here and that area there. Okay, so now we just have to find the area of 2 triangles. They're both above the x-axis, so therefore it's going to be positive. So we have a base, which is 2, times the height, which is 2. So that's 4 divided by 2, which is 2. So base times height divided by 2. Here we have 1, and then times 1, which is 1, divided by 2. So that's going to be 1/2, and that's going to give us 2.5 as our integral. All right, here we have another semicircle with a radius of 1, but it's going to be shifted up 1 unit. All right, so let's see if we can figure out what this is going to look like. All right, so we have a semicircle that would normally look like this, but it's going to be shifted up 1 unit. So it's going to basically look like this. Let me draw it in yellow here. It's going to look like this. And underneath it is going to obviously be some sort of rectangle. So once again, if we break this up into the semicircle, and then underneath it we have the rectangle, then we should be able to find, it looks like a burger, doesn't it? All right, we should be able to find the entire area here. All right, so let's see. The semicircle is going to have an area of pi r squared divided by 2. R is 1, so pi over 2. And then the rectangle is going to be, well, it looks like we're going from -1 to 1, so that's going to be 2. And then the height is 1, so 2 times 1 is 2. So pi over 2 plus 2. Okay, this last example here, we are integrating from, we have a graph with line segments as shown in the figure. And so basically, we just need to find area, basically from 0 to 1, from 3 to 4, and from 0 to 7. So 0 to 1, let's rewrite this as negative, the integral from 0 to 1. We're going to pull that negative out there, and we're going to get f of x dx. So here's our f of x. We're going to integrate from 0 to 1. So basically, that is this area right there, which looks like a triangle. It is underneath the x-axis, so we got to make it negative. So the base is 1 and the height is 1. So 1 times 1 is 1 divided by 2 is 1/2. So that's going to be a negative 1/2. But you have to remember there's a negative in front. So when you multiply that, it's going to make it a positive value. All right, from 3 to 4, that's going to be this area right here from 3 to 4. But there's a 3 here, so we have to pull that outside of the integral. So that way we can focus primarily on just the integral from 3 to 4 of f of x. That is going to be a rectangle. So it's going to be a base of 1 and a height of 2. So 1 times 2 is 2. And times 3 is going to be 6. So 6 would be the answer to that integral. And then here we can actually do some interesting things here. 0 to 7. Now I want you to notice here that from 0 to 1 and from 1 to 2, there is some area that is going to be equal and opposite of each other. So they can cancel out. And then from 5 to 6 and from 6 to 7, there's going to be some area that's equal but opposite, because one's above, one's below, is going to cancel out. So essentially, let me see if I can highlight it. What we're interested in finding basically is this area right here. All right, looks like basically like a trapezoid. So we're going to break it up into, actually, well, we're going to break it up into a rectangle and a trapezoid. All right, so let's go ahead and do that. So the area of the rectangle is going to go from 2 to 5. That's going to be 3 times 1, which is 3. And then if you remember the area of a trapezoid, it's going to be the height. Let's write that down. The height over 2 times the sum of the two bases. So the height of the trapezoid is going to be 1 over 2. And the base, or the bottom base, is 3. And the upper base is going to be 1. So that's going to be 4 divided by 2, which is 2 plus 3, which is 5. Okay, letter D, we have the integral from 5 to 11, f of x dx. And so once again, if you look at 5 to 6 and 6 to 7, that's equal but opposite areas, so that's going to cancel out. And then if you look once again from 9 to 11, well, 9 to 10 and from 10 to 11 is going to be equal but opposite areas, so that's going to cancel out. So basically, we are left with, let's see if I can draw it here. We're left with this area right here, which once again, well, this time it's going to be a rectangle, which actually a rectangle and a triangle. Now keep in mind that it's underneath the x-axis, so our final answer should be negative. So this rectangle has a base of 2 and a height of 1, so that's going to be 2, but it's going to be negative 2 because it's underneath the x-axis. And then this triangle is going to have a base of 2 and a height of 1. So base times height divided by 2 is going to give us 2 divided by 2, which is negative 1 because it's underneath the x-axis, so negative 3. All right, so now we want to see if we can erase all of this. Because now we want to, basically, we want to go from 0 to 11. All right, so let's see if we can cancel some things out here. 0 to 11. So that's going to be gone with that. And then 5 to 6 and 6 to 7 is going to be gone. And then 9 to 10 and 10 to 11 is going to be gone. And let's see here. Let's see, so we have a, looks like a 2 by 1 square there. And looks like we can make that a 2 by 1 square right there. So those are going to cancel out with each other. And basically, now all we have, well, you know what? We got something else that cancels out. I'll do that in blue. So this little wedge is going to cancel with that little wedge. And that little wedge is going to cancel with that little wedge. So after all that cancellation, we have two rectangles. And the one has a width of 1 and a height of 1, and this has a width of 1 and a height of 1, so it's going to end up basically giving us 2. All right. Okay, now we're going to go from 4 to 10. All right, same situation here. 4 to 10, so let's see what we can cancel out here. All right, so we have this little wedge right there, and that little wedge right there is gone. We have a rectangle there and a rectangle there. And then we have another little wedge right there and another little wedge right there. And we're only going up to 10. So basically, that leaves us with this triangle right here. And so this triangle is going to have a, looks like a base of 2 and a height of 2. So that's going to be 2 times 2 divided by 2. Base times height divided by 2, which is 2, but it's all underneath the x-axis, so that's going to make it a negative 2.